It is a type of assertion question, and the question is, graphite is an example of tetragonal crystal system. The reason are, for a tetragonal system, A is equal to B, which is not equal to C, and alpha is equal to beta is equal to 90 degree and gamma as 120 degree. The given options are option A, both A and R are correct and R is the correct explanation of A. The option B, both A and R are correct but R is not the correct explanation of A. The option C, A is correct but R is incorrect. And the last option, that is option D, both A and R are incorrect. Let's answer this question. Like quartz and ice, graphite is an example of hexagonal system. For hexagonal system, we know that alpha is equal to beta, which is equal to 90 degree, and gamma is equal to 120 degree, and A is equal to B and B is not equal to C. Whereas for a tetragonal system, alpha comma beta is equal to gamma, which is equal to 90 degree, and A is equal to B where B is not equal to C. Therefore, both the statements are false and hence the right option is option D. Let's move on to the next question. The cubic unit cell of a metal whose molar mass is 63.55 gram per mole has an edge length of 362 picometer. Its density is 8.92 gram per centimeter cube. The type of unit cell is A, primitive, B, face-centered, C, body-centered, and D, end-centered. Here we have the edge length as A is equal to 362 into 10 to the power minus 10 centimeter and the molar mass as 63.55 gram per mole, and the density is given as 8.92 gram per centimeter cube. We have to calculate the number of particles per unit cell to decide which type of unit cell it is. Therefore, Z is equal to question mark. From the relation of density, we have the formula as Z into M divided by Na into A cube. By rearranging the terms, Z is equal to D into Na into A cube divided by M. By substituting the values, we get Z as 8.92 into Avogadro number 6.023 into 10 to the power 23 into the edge length 362 into 10 to the power minus 10 the whole cube divided by 63.55. By simplifying, we get the answer as 4. Therefore, the metal crystallizes in FCC unit cell. And the right option is option B. A compound of A and B crystallizes in a cubic lattice in which the A atom occupies the lattice points at the corners of the cube. The B atoms occupies the center of each of the compound is. The given options are option A, A3B, option B, AB, the option C, AB3, and the option D as AB2. The solution is A atoms occupies the corners of the cube, Therefore, number of atoms of A is 1 by 8 into 8, which is equal to 1. B atoms occupies the center of each of the face of the cube. Therefore, number of atoms of B is half into 6, which is equal to 3. Thus, probable empirical formula of the compound is A1B3, and hence the right option is option C. The question is, which of the following compounds shows both Frenkel and Schottky defect? The given options are A. NaCl, B. AgCl, C. AgBr, and D. KCl. The solution is AgBr is the compound that exhibits Frenkel as well as Schottky defect. Therefore, the right option is option C. Moving on to the next question. The question is here. The fraction of total volume occupied by the atoms present in a simple cube is? The given options are option A, pi by 6, option B, pi by 3 root 2, option C, pi by 4 root 2, and option D as pi by 4. The solution is, for simple cube, the radius can be given as A by 2, and the volume of the atom is given by 4 by 3 pi r cube. By substituting the value of r in the equation of volume, we get the volume as 4 by 3 pi into A by 2 the whole cube. Therefore, packing fraction can be given as 4 by 3 pi into A by 2 the whole cube divided by A cube. By simplifying this, we get the final answer as pi by 6, and hence the right option is option A. Let's move on to the another variety of problem. The problem states in this manner. The first order reflection n is equal to 1 from a crystal of the X-ray from a copper anode tube whose wavelength is 1.54 angstrom occurs at an angle of 45 degree. What is the distance between the set of plane causing diffraction? The given options are option A 0.1089 nanometer, option B 0.1089 meter, option C 1.089 angstrom, and option D 1.089 into 10 to the power minus 9 meter. Let's write down the given data for the above question. Here we have the reflection as n, which is equal to 1, and the wavelength as 1.54 angstrom, and the angle theta is equal to 45 degree, and we got to calculate what is the distance between the plane, and it is given as d. The relation which satisfies the above data is given by n lambda is equal to 2d sine theta. By substituting the value n as 1, lambda as 1.54 is equal to 2 into d as it is sine of 45. And 1 into 1.54 is 1.54, which is equal to 2 into d, and sine 45 value is 1 by root 2. By simplifying, we get the distance as 1.089 angstrom. Therefore, the given right option is option C. Let's solve the final problem of the session. The question is, percentage of cation in ammonium dichromate is, the given options are option A 41.29%, option B 14.29%, option C 20.29%, and option D none of these. The solution for this problem is, percentage of the element or constituent can be given as number of parts of mass of element divided by molar mass into 100. And we also have molecular formula of ammonium dichromate, which is NH4 twice Cr2O7. From this, we can calculate the molar mass, which comes up to 2 into 14 plus 4 plus 2 into 52 plus 7 into 16, and the total is 252 gram per mole. Now, the number of parts by mass of cation, that is ammonium radical, which is NH4 plus, is equal to 2 into 14 plus 4, which is equal to 36. Therefore, percentage of ammonium radical is 36 divided by 252 into 100, which is equal to 14.29%. Therefore, the right option is option B.